In this video, we are going to cover 9.4 chemical properties. At the end of this lesson, students should be able to explain the chemical properties with reference to reduction to alcohol using LiAlH4 followed by H3O+, or NaBH4 in methanol, or H2 with catalyst, condensation with ammonia derivatives such as hydroxylamine, hydrazine, phenylhydrazine, and 2,4-dinitrophenylhydrazine as identification tests for carbonyl compounds. Oxidation with KMnO4H+, or Cr2O7H+, and the last one, iodoform test to identify methyl carbonyl group. Secondly, predict the products formed by reactions of carbonyl compounds with regions in A, 2, 3, 4, and 5 Roman. We know that there is 4 main types of reaction for carbonyl compounds, which are nucleophilic addition, reduction, condensation, and oxidation. In this video, we are going to focus on reduction, condensation, and oxidation. The first one is the reduction of carbonyl carbon double bond oxygen. The reducing agents are LiAlH4 followed by H3O+, or NaBH4 in methanol or ethanol, or catalytic hydrogenations, hydrogen with Pt or hydrogen with nickel. Reduction of carbonyl. If we have a carbonyl compound undergo reduction with the reducing agents mentioned before, the carbonyl part will reduce into alcohol. The carbon double bond oxygen is lost. The carbon will now attach to OH and another hydrogen. For example, we have propanol that is being reduced to propanol. The same goes for the following examples. The carbon double bond oxygen is lost. The carbon is now attached to OH and another hydrogen. You have to remember that when a compound contains both carbon double bond oxygen and carbon double bond carbon, selective reduction of one functional group by proper choice of reducing agent. If you want to reduce the carbonyl part, the reducing agent suitable are LiAlH4 followed by H3O+, or NaBH4 in methanol. But if you want to reduce the carbon double bond carbon, the suitable reducing agent to use is hydrogen and the catalyst nickel, or platinum, or palladium. Condensation with ammonia derivatives. A condensation reaction is a chemical reaction in which two molecules combine to form a larger molecule with the elimination of a smaller molecule such as water, ammonia, or HCl. In condensation reaction, between carbonyl compounds and ammonia derivatives, the elimination will be H2O. Consider the following reaction between a carbonyl compounds and ammonia NH3. The oxygen from carbonyl compound and 2 hydrogen from ammonia is eliminated as water. The carbon is now double bonded to nitrogen. This product is called imine. Look at the following example. We have a reaction between carbonyl compounds and ammonia derivatives called 2,4-dinitrophenyl hydrazine. The oxygen from the carbonyl compound and 2 hydrogen from 2,4-dinitrophenyl hydrazine is eliminated as water. The carbon is now double bonded to the nitrogen of 2,4-dinitrophenyl hydrazine. If this reaction is carried out in an experiment, a yellow or orange precipitate is formed. The following example shows the reaction of carbonyl compound with hydroxylamine, hydrazine and phenylhydrazine. We can see here the oxygen from the carbonyl compound and 2 hydrogen from the ammonia derivatives is eliminated as water. The carbon from the carbonyl compound is now double bonded to the nitrogen of the ammonia derivatives. Oxidation. Aldehydes are easily oxidized to carboxylic acid by strong oxidizing agents. Ketones are resistant to oxidation because they do not have hydrogen attached to the carbonyl carbon atom. The oxidizing agents commonly used are acidify KMnO4 under heat or acidify K2Cr2O7 under heat. Please remember, oxidation only occurs for aldehydes. The general reaction is as follows. If we have an aldehyde that undergo oxidation, the carbonyl part will oxidize into carboxyl side, which means the aldehyde is oxidized to carboxylic acid. For example, we have propanol. If propanol undergo oxidation, the C double bond OH will turn into C double bond OOH, which is a carboxylic acid. The same goes for the following example, cyclopentylmethanol. If cyclopentylmethanol undergoes oxidation, the carbonyl part will oxidize into carboxyl part, and the product will be cyclopentylmethanoic acid. Another chemical properties for carbonyl compounds is iodoform test. This test is used to detect the presence of methyl carbonyl group. If this group is present in the carbonyl compounds, a yellow precipitate will form. So what is methyl carbonyl group? Methyl carbonyl group is carbon that is double bonded to oxygen and single bonded to CH3. As you can see in the following structures, the structures on the left has methyl carbonyl group as well as the structure in the middle, but the structure on the right does not have methyl carbonyl group. So how do we write the equation for iodoform test? If the reaction use I2/OH minus, the structure of the product would be the carbonyl group and the CH3 is replaced with O minus plus CHI3, and we draw an arrow pointing downwards to represent a precipitate. So this precipitate is a yellow precipitate. Another way to write the equation for iodoform test is by using I2/NaOH. The product will be CH3 is now replaced with O minus Na plus CHI3 with an arrow pointing downwards. Another way to write the equation for iodoform test is by writing 1 Roman I2/NaOH followed by 2 Roman H3O plus. The product now is CH3 being replaced with OH plus CHI3 with an arrow pointing downwards. That's all for this video. Thank you.